This is a draft presentation for an automatic winder for the Qrc tower clock. The tower clock has 3 weights, each weight approximately weighing up to 500 pounds, and it's cranked through a crankshaft shown on the screen here. There are 3 crankshafts, and this is like a socket set. What we see here are extension socket sets so that we can wind up by turning these, which attach to the crankshaft inputs of the clock, and duplicate the crankshaft extended there. These are the 3 orange items. What we see there in the blue and white are engagers. That engages the crankshaft to an outer cylinder, which will be popping up in a while. There it goes in pink. The outer cylinder in pink, which I call the grabber or grappler, is connected to a toothed chain wheel, very similar to the wheel on a bicycle pedal, which is driven by chain to an electric motor. The outer pink grappler turns independently of the shafts, the orange shafts, and what engages it is the engager, the blue and white end caps there, which will grab on to the pink outer shaft. If we see in the middle pink outer grabber is connected to the toothed chain wheel. This is what's similar to the bicycle pedal, and above it is a motor that drives that wheel through chain drive, which is not shown. The chain drive wraps around all the wheels, and they will be shown shortly, 3 wheels over the 3 pink grapplers. We see here a teddy bear plate that the shaft axis is mounted on, both the inner and outer, as well as the motor. And then we see another yellow L-shaped plate that completes the mounting of the assembly for the middle winder. And now we see the triplication of the assembly. So the 3 big wheels in blue are all turning together, all driven by the chain, and drive that grappler, pink grapplers. Here it is in faster motion how it's all assembled, and we will recap. What we see here is a red train. The train runs up and down the tracks on the blue platform there, and this is to push the engager, the blue and white engager, so we could engage one motor at a time to be wound up. Shortly we will see how this works. Here's a view from the top, and you could see the bump pushes in that engager that engages the motor to drive the wind-up shaft, crankshaft. Here it is. We see all pink grapplers turning at the same time, but it's only the middle one that's engaged. By having a mechanical train, we cannot have 2 or more motors, not motors, but crankshaft engaged. Here's the crankshaft that attaches to the clock from the back side, and we shall see the middle one turning, but not the other 2. Here's a closer view of the engager. The pink is the grappler that turns independently, as we will see shortly. It turns independently of the crankshaft in orange because the engager is not attached. It's turning independently. Now we will turn the crankshaft, the orange, which is attached to the blue and white. Here we go, and that's turning independently. And finally we'll see it together. Next we will see the train, the red train. As you see from this view, it runs up and down the tracks. And this engages only one motor at a time. This is just a fast run, but in actual practice, sensors will stop it when it reaches its home position until it's ready to go back home. Here's a view of the backside, which connects to the clock. The hand there behind the motor is just to give reference so one can relate to the dimensions. The motor is an actual measurement of an off-the-shelf purchased item, and that is an actual measurement of my hand. And here is a view of the mechanism working with the train in position, pushing in the engager and grappling on and connecting the motor drive directly to the middle orange crankshaft. Note in the teddy bear there are slots. These are to attach bearing guides for the chain so that the chain is properly wrapped around each toothed wheel, as well as to take up slack. And this is just about the end of this demonstration. And here is a picture of Queen's Royal College, the main building. Thank you very much.